In this video, we are going to go over homogeneous functions. Here are the following examples we'll go over.
To test if something is homogeneous or not, we're going to be looking at this f of xy part. We're going to be modifying it so we have another variable inside of it, and we'll use t for this. We'll have f x of t, comma, y t. And now we're going to set this equal to our equation. We now have to change our equation since we no longer have x and y, we have xt and yt. So inside of our equation, we're going to have xt plus yt to the fourth power. Easy way to think of this is just adding a variable with our x and y. Now, to see if it's homogeneous or not, depends on if we can factor this variable out and be left with our original problem. So if we factor a t out of here, we can see that our lowest power is the cubed. So we're going to factor out a t cubed. And we're going to be left with an x plus yt inside of here. This should be y to the fourth t. We can test to make sure that this is what we had earlier by distributing our t cubed back into our problem. We're not going to look at what we factor out. We're not looking at this t anymore. We are looking back at our equation. Now, we can see that our equation still has a t inside of it. And if our equation still has a t inside of it, that means it is not back to where it was originally, which means it is not homogeneous. For it to be homogeneous, there would have to be no t inside of our original equation. For b, if we modify our f side to include a t, we can rewrite our equation to be x of t plus the square root of yt. We can see that we also cannot factor out a t out of this because our t is inside of our square root. So this is also not a homogeneous function. We're going to look at c now, and we can see that if we write f, x of t, and y of t, and put t inside of our function, we're going to get xt cubed times yt, and this is in parentheses cubed. So we can actually factor out our t here because it is the same. It's going to be t to the 9. So we factor this out, we have t9, and then we're going to be left with x cubed times y cubed, which is the same as our original formula. So that means c is a homogeneous function. For d, if we plug t into our equation, we are going to get an x squared times t squared, and then a sine, and then inside of here we are going to have our yt, and this is going to be squared. We can't factor out a t in here since it's inside of our sine, so this is not a homogeneous function. E is pretty interesting. We're going to do this in green, and if we plug in our t's here, we're going to see that we have an x squared times a t squared times our y cubed times a t cubed minus a y to the fifth times t to the fifth plus x to the fourth times t to the fourth times y times t. If we look at this closely, we're going to see that we have t to the fifth for all parts of our problem. So if we factor out this t to the fifth, we are going to be left with our original equation. That means that e is also a homogeneous function. For f, if we plug in t's, we can see that they would just cancel out and we would be left with our original function. So f is also a homogeneous function. For g, if we have our t's plugged in here to test it, we're going to have an x cubed times t cubed, and then a y to the fourth times t to the fourth, plus our x cubed times t cubed plus y to the fourth times t to the fourth. We can already see that after plugging in the t the third time, that we are not going to be able to completely factor out all of the t's. This means that g is not a homogeneous function. For part h, if we plug in our t into the equation, we are going to get the square root, and then inside of our square root we'll have our x cubed, a t cubed, and then a plus y cubed, followed by a t cubed being multiplied onto it. In doing this, we can factor out the t's inside of our square root, and we're going to get a t cubed, and then in parentheses an x plus y. Both of them are going to be raised to the third power. If we do this, we can then take the square root of our t and move it away from our function. We'll have t to the square root of t, and this is all by itself being multiplied by the square root of x cubed plus y cubed. In doing this, we see that we have the original equation right here. It matches what we were given. So that means h is a homogeneous function. For part I, if we just put a t in there, we can factor it out and see that we have a t cubed. After we do this, we no longer have a t anywhere in our original equation, so this is also a homogeneous function. That means for all of these, we have c, e, f, h, and I that are homogeneous. Everything else is not a homogeneous function, and once again, to test if something is homogeneous or not, all you have to do is plug in a t to the f area, so you'll get fx of t and y of t, and then plug in the t into the equation. After you do this, you try to factor out the t, and if the t's all factor out and you're left with your original equation, that means it is homogeneous. If you try to factor it out and you still have t's left in your equation, it is not homogeneous. I hope this video helped. If you enjoyed it, consider leaving a like. If you have any questions about any of the material we covered in this video, leave it in the comments below, and I will do my best to get back to you.
Yeah?
Hello? Okay, do you like tulips?
Yes.
Then you're gonna love to put your tulips on these nuts.
Oh my god. Yes, hello here.
Alright, bye, have a good day.